Welcome to this video on the shape of data. By the end of this video, you should be able to describe data by its shape and by how many peaks it has. You should be able to decide what measures of center and variability to use based off the shape of the data. And you should be able to describe the shape of a data set. So let's take a look about naming data sets by how many peaks it's got, meaning what is the tallest spot. So if we call the data set unimodal, if there is one peak. Okay, so all of these right here below, those are all unimodal. They have one peak. It doesn't have to be in the center, it's just one tallest spot. So bimodal, if you remember the prefix bi means two, bimodal would mean that there are two peaks. Now we will describe a distribution as bimodal even if the peaks are not the same height, so they do not need to be the same height. Okay. After two peaks, we're just going to call it multimodal. That means more than two peaks. All right, and our last one is uniform. Uniform means no peaks. It's pretty much flat across the top. Everything is about the same. All right, so we have a review here of the shapes of the data. We have symmetric. Remember, if we loosely throw a blanket over the top of this, we get this symmetric. And this is the only shape. We had some shapes that would go up and down and then back up and down again. That is also symmetric. Skewed right has a tail on the right. If I loosely throw a blanket over the top of this, and it kind of starts to look like a whale. Okay, his tail is on the right, so we call him skewed right. And our left skew, he's got a tail on the left, so we call him a left skew. Okay, so this is our histograms. Here's versions in our dot plots, the same idea. You can see the nice symmetrical. Here, we have a little bit of bump, but you can see there's still a tail to the right, so that makes it right skewed. And same over here, we have a tail on the left, so that's going to be left skewed. Box and whisker plots can be a little bit harder to see, but we want to look at the whiskers. The whiskers are approximately the same. We're going to call it symmetrical. So when we have a box and whisker plot, we can pretend to throw a blanket over it, and the box is where the peak is. Okay, the box is where the peak is, and then it's going to come down. The box is where the peak is, and then it's going to come down. So the longer whiskers on the left, making it left skewed. The longer whiskers on the right, making it right skewed. So let's give a little bit of words to kind of help us with this. To be symmetrical means the data from the center, the data on the left and right, will mirror each other. Okay, so it doesn't have to be exact, but you get the idea that from the center, it's going to be approximately the same look left and right from there. Okay, for a skewed right with the tail on the right, most of the data values are lower. Because remember, this is on a number line. So when we have more data values to the left, they're lower numbers. So they're lower meaning to the left. We only have we have fewer to the right, which makes this little tail here. Now that could be the reason you could be right skewed. One of the reasons is you could have an outlier on the right. Okay, so if you're right skewed, there could be an outlier over here that drew that over. It doesn't have to be an outlier, though. It's just one of the possibilities. Now, for a left skew, it's a very similar idea. On a right skew, most of the data values are lower, meaning to the left. Well, on a left skew, most of the data values are higher. which means more of the data values are to the right and fewer of them are to the left. One possibility that's creating this tail on the left is you could have an outlier on the left-hand side. All right, so that just gives you a little bit of a verbal description of our different shapes. So let's look at some examples. So remember, when determining what measure of center you should be using, the shape of it makes a difference. Okay, so if we're symmetrical, so I'm going to draw, we could have that, like a mountain, or like two mountains that are about the same. So this one would be bimodal because it has two peaks, but this symmetrical one is unimodal because it only has one peak to tie it all together. Now, when you're symmetrical, the mean is equal to the median. It might not be exactly equal, but they're pretty close together. If you're symmetrical, the mean is equal to the median. So it really doesn't matter which one you use, but we tend to use mean in that case. Okay? If we're skewed right, remember our tail is on the right. That means our mean is going to be greater than our median. The mean will be larger. So I'm going to write that the mean is greater than the median because remember from previous, it gets pulled further. So we would have our mode here, the median is still in the middle, and our mean will get pulled furthest. Okay? Your median's in the middle. So if you're skewed right, because the mean gets pulled further, the median is closer to the center. We want to use it to describe the center. If we're skewed left, that means your tail is on the left. Then your median is going to be larger. And what I mean by that is your mean will be less than your median because the median is larger. So your mode is still the highest spot. Your median is still in the middle, but the mean got pulled furthest to the left with that tail. And remember, these are on a number line. So the mean went further, so the median is greater than, or the mean is less than the median. Okay? Now our uniform is when it's pretty much flat across the top. Remember, when we were discussing uniform is also symmetric. Well, whenever you're symmetric, then your mean is pretty much equal to your median. Okay, so we're going to use that and look at some shapes and see how the means and the medians compare. All right, so here we have a shape. There's a tail on the left, making it left skewed. If we're left skewed, the mean is less than the median. So how does the mean compare to the median? I'm going to say the mean is less than the median. Okay. Are we going to use the mean or the median to describe the center? Because the mean got pulled so much further, the better representation of center is the median. So we're going to use the median. And then do we want to use range or IQR to describe the variability? Because it is skewed, we want to use IQR here. All right, let's try this again. I'm looking at this box and whisker plot and I'm noticing this right tail is longer. That means it's right skewed. So when I look at the right skewed, that means the mean is greater than the median. Anytime you have skewing, you want to use the median to describe your center, and you want to use IQR to describe your variability. All right, our third example, I'm going to throw kind of a blanket over the top of this. This is pretty symmetrical. It might not be 100%, but it's pretty close to symmetrical. That means our mean is going to equal our median. They appear right here in the center together. Now, when we're symmetrical, we want to go ahead and use the mean to describe it. So there's our mean, and for variability, we're going to go ahead and use the range. one last one. I'm going to throw a blanket over it, and you can see the tail on the right. It's much longer on the right. So if it's skewed right, that means your mean is greater than your median. And anytime you have skewing, then you want to go ahead and use the median for your center because it's not pulled off as far. And you want to use IQR for your variability. Alright, so hopefully you're starting to see when we should use mean and when we should use median and when we should use range versus when we should use IQR. One last, we're just going to go back to how we can name by peaks. So when we look, if I draw this loosely over, I have 2 peaks, and 2 peaks is bimodal. Okay. For my second example, I throw the blanket over. It is flat across the top. There are no peaks. We're going to call that uniform. For a third example, throw the blanket over it. There are 3 peaks there. They don't have to all be the same height, but we end up with 3 peaks. So we're going to call that multimodal. And then for our last one, remember we're describing by peaks, not by shape. That would be symmetric for shape, but there's only 1 peak. Even though there's 2 tall bars side by side, they only make 1 peak. So this is going to be unimodal. Alright, hopefully that was helpful. Let me know if you have any questions. See you in class.